This is the fifth video in the section, Regression Accuracy and Model Persistence. In the previous video we learned how to build a linear regressor. In this video we're going to take a look at computing regression accuracy and we'll see how to achieve model persistence. Now that we know how to build a regressor, it's important to understand how to evaluate the quality of a regressor as well. In this content, an error is defined as the difference between the actual value and the value that is predicted by the regressor. Let's quickly understand what metrics can be used to measure the quality of a regressor. A regressor can be evaluated using many different metrics. Mean absolute error. This is the average of absolute errors of all the data points in the given dataset. Mean squared error. This is the average of the squares of the errors of all data points in the given dataset. This is one of the most popular metrics out there. Median absolute error. This is the median of all the errors in the given dataset. The main advantage of this metric is that it's robust to outliers. A single bad point in the test dataset wouldn't skew the entire error metric as opposed to a mean error metric. Explained variance score. This score measures how well our model can account for the variation in our dataset. A score of 1.0 indicates that our model is perfect. R-squared score. This is pronounced as R squared, and this score refers to the coefficient of determination. This tells us how well the unknown samples will be predicted by our model. The best possible score is 1.0, and the values can be negative as well. There is a module in scikit-learn that provides functionalities to compute all the following metrics. This is the code where we're printing the mean absolute error, mean squared error, median absolute error, explained variance score, and R-squared score. Let's run the code. There is an error. Okay, we have to go back to the editor. We need the y-test defined as the linear regressor. We'll just uncomment that. Let's see if it works. Yes, so you can see the output. Keeping track of every single metric can get tedious, so we pick one or two metrics to evaluate our model. A good practice is to make sure that the mean squared error is low and the explained variance score is high. Now, next is achieving model persistence. When we train a model, it would be nice if we could save it as a file so it can be used later by simply loading it again. Let's see how to achieve model persistence programmatically. For that, we add these lines to regressor.py. The regressor object will be saved in the 3_model_linear_regr.pkl file. We'll then load it and use it. This is the code to load it. Here we just loaded the regressor from the file into the model_lin_regr variable. You can compare the preceding result with the earlier result to confirm that it's the same. Finally, run the code. As you can see, the new mean absolute error is 0.54. In this video, we've learned about computing regression accuracy and achieving model persistence. Awesome! In the next video, we'll learn about building a ridge regressor.